Welcome, everyone. I'm excited to kick off our presentation today. We'll be exploring part-whole models, a fascinating topic in understanding how things are structured and related. This is the introduction slide, so I just want to give you a quick overview. We'll start with some basics, then dive into how these models work and why they matter. So, let's get started and enjoy the journey through this engaging subject. Have you ever shared some sweets with your friends? We have 7 sweets altogether, and this is the whole amount. When we talk about breaking numbers into parts, we're really looking at how we can split this total into smaller, more manageable pieces. This helps us understand the value of each part and see how they add up to the total. It's a key idea because whether we're sharing treats or solving math problems, understanding how to divide a whole into parts is really useful. So, as we go through this, remember that breaking numbers into parts is a way to make complex numbers easier to understand and work with. Can you think of another way to make 7? Sometimes, it's helpful to think about splitting a number into smaller parts. Have you ever shared some sweets with your friends? Imagine you have 7 sweets. Instead of giving them all at once, you can split them up. We can divide 7 into 2 smaller parts in different ways. For example, one child might get 4 sweets, and another might get 3. Notice that 3 and 4 are 2 smaller parts that add up to the whole, which is 7. This idea of breaking numbers into parts is a very useful way to understand how numbers work. It helps us see that numbers can be made up of smaller pieces, and this is a key concept in understanding addition and subtraction. So, whenever you see a number like 7, think about how you can split it into parts. It makes math more fun and easier to understand. Let's take a closer look at the idea of a whole and its parts. When we talk about a whole, we're referring to the complete amount or number. A part, on the other hand, is a section or piece of that whole. Sometimes, we break a number into smaller parts to better understand it or to make calculations easier. A part-whole model is a visual tool that helps us see these relationships clearly. It shows us the whole and how it can be divided into parts, or how parts come together to make the whole. Think of it as a simple diagram that looks like this. The whole is at the top or on one side, and the parts are connected to it below or within it. This visual makes it easier to understand the different ways we can break a number into smaller, manageable parts. So, a part-whole model is really helpful for understanding how numbers work together, especially when we're learning to add, subtract, or understand number relationships overall. Today, we're looking at an example where there are a total of 7 sweets. This represents the whole, or the complete set. When we think about how to make a part-whole model, the key idea is to show how parts make up the whole. This helps us understand the relationship between smaller groups and the entire set. Remember, it's important to clearly identify both the parts and the whole to see how they connect. This approach is really useful when we're trying to break down complex information into simpler, more manageable pieces. So, in this example, the 7 sweets are the whole, and any parts we might divide or analyze are smaller groups within that total. This method helps us visualize and understand the structure of the data or problem we're working with. So, in this slide, we see that one child had 4 sweets, and the other child had 3 sweets. These numbers represent smaller parts that together make up the whole. The total number of sweets is 7, which is the sum of these 2 parts. This is a great example of how we can break down a whole into smaller, more manageable parts. When we build a part-whole model, we're essentially showing how individual pieces combine to form a complete set. The key point here is understanding the relationship between the parts and the whole. By visualizing it this way, it becomes easier to see how parts come together, which is really important for understanding addition and subtraction concepts. Remember, this approach helps us see the bigger picture by focusing on the parts, and it's a useful tool for solving many math problems. So, when we're creating a part-whole model, we start by identifying the parts, then show how they add up to the whole. Now, here we see one plate with 5 slices and the other plate with 3 slices. This is a great way to visualize parts of a whole, especially when we're working with fractions. The pizza itself is cut into 8 slices, which makes it easier to understand how these parts relate to the entire pizza. When we talk about making a part-whole model, we're essentially showing how smaller pieces, like these slices, come together to form the whole. Understanding this helps us see how fractions work. Each slice is a part of the total, and by counting the slices, we can understand the size of each part relative to the whole pizza. This visual approach is a powerful tool for connecting individual parts to the bigger picture, which is key in mastering fraction concepts and applying them to real-world situations. Let's take a closer look at the smaller parts of the whole number. We see the numbers 3, 5, and 8 listed here. These are the parts that make up the larger whole. Now, the big question is, what is the whole number? That's what we're trying to find out when we build a part-whole model. Creating this model helps us see how the smaller parts fit together to form the entire number. It's a visual way to understand addition and how numbers combine. So, when we make a part-whole model, we start by identifying the smaller parts, and then we see what they add up to. This approach is super helpful in understanding the relationship between parts and the whole, which is a key idea in math. Remember, the goal is to connect these parts to the entire number, making it easier to understand and solve problems involving addition and subtraction. Let's take a look at this part-whole model. On the slide, you see the numbers 4, 5, and 9. Now, what would this look like in a visual model? Imagine dividing a total into parts. So, how many pink counters are there? That's right, 4. And how many blue counters? Yes, 5. When you add those parts together, what do you get? 9, which is the total. This simple model helps us understand how parts make up a whole. It's a great way to see the relationship between different quantities and the total. Think of it as a way to break down a bigger number into smaller, manageable pieces. This idea is fundamental in understanding more complex math concepts later on. So, whenever you're working with parts and wholes, remember this visual approach. It makes the math clearer and helps you see the connections more easily. All right, let's take a look at this slide. Here, we have a sequence of options labeled next. Try again, D, C, B, and A. The question is asking us which part-whole model can be used for the counters shown above. Now, I want you to focus on the options D, C, B, and A. These represent different ways to visualize how parts make up a whole, which is at the core of the part-whole model. When selecting the correct answer, think about how the counters are arranged and what kind of model best represents their relationship. Is it a simple grouping, a partition, or a more complex structure? Remember, part-whole models are all about understanding how individual parts come together to form a complete entity. So, as we go through this, keep in mind what the counters look like and how they relate to the options. This exercise helps us deepen our understanding of how to visually represent parts and wholes, which is a key concept in understanding numbers and their relationships. All right, let's take a look at this slide. Here, we've got a sequence of options. Next, try again, D, C, B. A. The question is asking which part-whole model can be used for the counters shown above. Now, remember, part-whole models are great for helping us understand how smaller parts make up a whole. When we see options like these, it's important to think about how the counters relate to each other and to the total number. As we consider the options, think about which model best represents the relationship among these counters. For example, if the counters are parts of a larger set, which model would best illustrate that? This question helps us reinforce our understanding of how to use models to visualize numbers and their relationships. It's a good way to check if we grasp how parts combine to form a whole, which is fundamental in understanding number composition and decomposition. So, take a moment to consider the options carefully and choose the model that clearly demonstrates the part-whole relationship for these counters. Let's look at this simple example. 6 plus 4 equals 10. When we add these two parts together, we're creating a whole. Part-whole models are really helpful tools that can guide us through solving addition problems like this. They help us see how smaller parts combine to make a larger total, which is a key concept in understanding addition. By using these models, students can visualize the process and develop a stronger grasp of how numbers work together. This approach ties into our overall theme of building a solid foundation in math skills, making abstract concepts more concrete and understandable. All right, so here we have a simple example to help us understand part-whole models in addition. We know that one of the parts is 5, and if we look at the equation, 5 plus something equals 12. The question is, what is that missing part? And the whole or the total is 12, the answer to the addition problem. This shows us how part-whole models work. They help us break down a problem by showing the parts that make up the whole. In this case, if one part is 5 and the total is 12, we can think of the missing part as the difference between 12 and 5. Part-whole models are really useful tools because they help us see the relationship between parts and the whole, especially when we're solving for a missing number in addition problems. They make it clear how the parts fit together to make the total, which is a key concept in understanding addition. By visualizing these relationships, we can better understand how numbers work together and develop stronger problem-solving skills. So remember, whenever you're stuck on a missing number, think about the parts and the whole. It's a powerful way to figure things out. Now, let's look at how the number 7 becomes the second part of the model. When we take 4 away from 11, it leaves us with 7. So, in the subtraction problem 11 minus 4, the 11 is the whole number, the total amount we start with. This example shows how part-whole models can really help us understand subtraction better. By visualizing the whole as being split into parts, we can see how taking away a part affects the whole. These models are a great tool for making sense of subtraction problems, especially when you're trying to see the relationship between the parts and the whole. Remember, the key point here is that the first number in the subtraction question tells us the whole, and breaking it into parts can make solving these problems much clearer. Now let's look at this example. Gemma had 15 apples and Ben had 6 apples. The question is, how many apples did they have altogether? When solving word problems like this, especially with addition, it's helpful to think of the problem as a whole, which is where part-whole models come into play. Part-whole models help us visualize how different parts, like Gemma's apples and Ben's apples, combine to make a total. So, in this case, we're adding 15 and 6 to find the total. Notice how the numbers are shown here. 15, 6, and their sum, 21. The equation 15 plus 6 equals 21 summarizes what we're doing, adding the parts to find the whole. The key point is, when solving word problems, breaking the problem into parts helps us understand what we're combining and makes the math easier to do. This approach ties into our overall theme of understanding how to use models to solve real-world problems. It's a powerful tool that helps us visualize and organize information before we do the calculations. Let's look at this problem. Sam has 12 apples. He gives 5 to a friend. So how many apples does he have left? When solving word problems like this, using part-whole models can really help us understand what's happening. We start with the total, which is 12 apples, and then we subtract the part that was given away, which is 5. The question is, what remains? Remember, the key idea here is to think of the total as a whole, and the part given away as a piece taken out. This helps us visualize the problem clearly. The main concept is that subtraction models the part of the whole that's been removed. By understanding the problem this way, we can easily find out how many apples are left. So, in this case, we just subtract 5 from 12 and find out that Sam has 7 apples remaining. This approach connects directly to our overall theme of using part-whole models to solve word problems efficiently and accurately. So, how would you rate your understanding of part-whole models? Think about it. 5 means you've got it completely, you're confident and ready to go. And 1 means you're still unsure, maybe a bit lost. This is a great way to gauge where you're at with this concept. Now, how can you use part-whole models in numeracy? Well, they're really powerful tools for understanding how numbers fit together, how parts make up a whole, and how to break down complex problems into manageable pieces. They help make abstract ideas more concrete and easier to grasp. What have you learned about these models? Hopefully, you've seen how flexible and versatile they are. They can be used for addition, subtraction, multiplication, and even fractions. They also support developing a deeper understanding of number relationships and structure. And overall, what do we know about part-whole models? We know they're essential for building a solid foundation in numeracy. They help learners visualize and organize their thinking about numbers, making math more accessible and meaningful. So, as you reflect on this, consider how you can incorporate these models into your teaching or learning practice, helping to make math clearer and more connected.